Hi everyone, it's nice to be here. I'm assuming some people may still be trickling in from lunch, but to make sure we end on time, I'm just going to go ahead and get started. Just wanted to say thank you to TypeSafe for putting this conference on and organizing everything. This is the first time I've ever spoken at Scala Days, although I've heard a lot about it, so it's great to be here. So this is a talk about our experience as a very active Scala, open source Scala project with Spark, our experience using Scala in the last few years. It's not really a talk about Spark specifically, but kind of how we interact with Scala, what we found works well and doesn't work well in writing a large project on Scala. So actually, before I really get started, I'm curious, show of hands, I'm going to ask a couple questions, like how many people have heard of Apache Spark before sitting down to this talk? Okay, so that's maybe like 90% of people. How many people have like used Spark before in some context, even just kind of playing around? All right, so that's down to maybe 20%. Last question, how many of you went to the earlier talk about Spark at this conference? That's maybe 30%. Okay, great. So yeah, so I will give a little bit of background on Spark. Spark is a execution engine for doing very large-scale data analytics. It's a piece of software. It's written in Scala. It's under the Apache Foundation. And the API is inspired by Scala collections, so it'll be familiar for anyone who works with collections regularly in Scala. We also have many language APIs in Spark. So we have not only a Scala API, but we have Java and even non-JVM APIs for Python and R. And the project itself has, we have this lower level kind of collection-based API for doing large-scale data processing, but we also have high-level libraries in Spark SQL, machine learning, and streaming. So it kind of looks like this from an architecture perspective. We have the core engine at the bottom that has interoperability with many types of data sources that people use in kind of the big data space, different storage systems. And we then have these more domain-specific libraries on top, and we have multiple language APIs across the whole thing. So the types of problems that are hard with large-scale analytics, we have to deal with things like fault tolerance. People run Spark on clusters of tens or hundreds of machines, and we need to deal with random failures happening. We also need to understand how to parallelize. The user comes to us with a more declarative statement of what they want to do, and we need to go and chunk that up into parallel pieces and execute it across a large cluster. So these are the types of engineering problems that people don't want to solve themselves, and so they use a data analytics framework like Spark. But again, I'm not really going to talk a lot about what Spark is today. There's lots of other cool talks about Spark, and I'd encourage you to check those out if you're interested in really the nuts and bolts. But the dynamics of Spark are pretty interesting. So we created the project at UC Berkeley in 2010, roughly. This is the number of contributors per month we've had on the project over the last few years. And as you can see, it's like really exploded, especially in the last 2 years in terms of just the overall activity and engagement in the project. We started the company Databricks, which I'll talk about in a second, in 2013, and so you can see that was obviously very closely associated with a large increase in activity. But today, Spark has like hundreds of people every month who work on it, which is very, very active. That actually makes us the most active project in all of the Apache Foundation. That includes all of the Hadoop projects, Apache Server, and a bunch of other really very well-known and active projects. So, we're right at the top of this list. And in terms of how many people have adopted it, there's at least like 500 known production deployments that we've categorized at Databricks. It's open source. I'm sure there's way more people using it than that. But basically, it's a fairly widely adopted project, so we get a lot of feedback from real users in the way that we think about designing and building Spark. I'm just going to give one code example of a very brief Spark program. So one thing we have is we have a REPL. It's inspired by and basically a fork of the Scala REPL. So we can interactively crunch very large data sets in Spark using an API that will be very familiar for people who have programmed with Scala collections. I'll walk through this really quickly. The nuts and bolts of it aren't too important, but essentially what you have here is an interactive session. So the first thing you do is you use Spark's utility to load a file in HDFS. That's a big distributed file system, and say, treat this as a big collection of individual records. You get back what's called an RDD, which is basically a collection. So you get this lines object, and here you're doing some interactive analysis on a large data set to look at error messages that occur in maybe some web logs. So you might filter the original data set to find messages that log lines that only contain errors. That creates a new RDD called errors. You can then map that to extract only one field. So maybe you want to look at just the message, not only kind of the other fields. And you can cache it. We also support this kind of in-memory caching of data sets. And then you can do another filter to say, I only want to see errors with MySQL, and then count how many of those there are in your entire sort of underlying data set. So this is kind of the flavor of the lower level Spark APIs. The higher level APIs tend to be a little bit more domain specific. So it's more like invoke k-means on this data set. It's kind of specific to those programming models rather than having this lower level sort of collection based. But you get a little bit of a sense of what Spark looks like in here. So I work at Databricks. So Databricks is a company that was founded by the creators of Spark, and we spend a lot of effort building Spark. We're leading all of the development. We also have our own software product called Databricks Cloud. So that's Spark as a service. It's basically a hosted environment that allows you to instantly spin up Spark clusters and deals with enterprisey things like security and multi-tenancy and some visualization on top of Spark and stuff like that. But of note here is that all of our software pretty much is written in Scala in the entire company. So there's about 35 engineers. Everyone's working on Scala for the Apache Spark component, but also for our internal infrastructure. And last background slide about me. So I was at UC Berkeley trying to get a PhD. I actually didn't finish my PhD because I started working on Spark, and I thought that was really cool. And then we left to start this company, Databricks. So I'm kind of on hold of finishing my PhD and helping get Databricks started. What I do there is I do release management and team management for Spark, so I'm pretty clued into kind of how the project runs and how we think about the programming language runtime that Spark is built on. My background personally is really in systems and networking. That was what the focus of my PhD was. It's not in PL at all, so I'm a total noob when it comes to PL concepts, and only through using Scala have I really kind of gotten excited about PL ideas and functional programming, but I am absolutely a very beginner in this whole area. So this talk is really kind of to provide feedback and advice to people who are using Scala for their own projects. And it's kind of a retrospective of, we've been using Scala for almost 5 years, building Spark, and what has been our experience and what are things we think works well in the community and in the way the language is built, and what are things we've had issues with. So there's a little aspect of unsolicited feedback here. No one came and asked what I feel about Scala, but I do think that it's healthy to have a dialogue in any community, including this one, around what are the impressions of people who are building on this infrastructure. How do they feel about it? So first I'll talk about our overall impressions. Really this is a lot of my opinion, but of course I'm reflecting the way all of us that work on Spark feel about Scala. So I'm actually about to get married this summer, and so I'm thinking a lot about kind of commitments and relationships and so forth, and I thought it was an apt analogy to say that using a new programming language is kind of like falling in love. At the beginning, you're in the honeymoon phase, you think about all these crazy new cool things that you can do that you couldn't do before, and over time, you start to see not only the good things, but areas where there's tension and there's friction, and the key to success is just making sure that you invest in the relationship, and you kind of define the modes of interaction that you're going to have a productive and healthy relationship. So Matej Zaharia, who created Spark, I showed him the slide deck beforehand, and he pointed to this slide and he said, "Oh, make sure your fiance doesn't see this when she's looking at it." I thought it wasn't too bad. I mean, this seems fine to me, but that was funny. So why did we choose Scala? I pulled this up. Someone asked Matej this on the mailing list. He was the creator of the project, and I came on pretty early, but after he had started it. And he said this. He said the answer is pretty simple. We wanted to accomplish two goals. We wanted to work with this Hadoop ecosystem that has a lot of legacy JVM code, and we also wanted to have a really concise programming interface that is functional in nature and lets users pass closures in. I mean, I'm paraphrasing, but that's basically what he said. And I think even looking back now over the last few years, those are really two of the main points and the main benefits we see of using Scala compared to writing it in Java or some other language. So to kind of distill in a little more detail, I think what makes Scala really useful to us is, number one, the compatibility with the JVM ecosystem. If we didn't have this, we never could have written Spark and Scala in the first place. There's just huge legacy investment in tons of code bases that we needed to directly interoperate with. Another thing that's really important to us, or that has been useful over the years, is the ability to write DSLs. Now, that comes with a big asterisk, which I'll talk about later in the talk. I think DSLs generally are overused in the Scala language ecosystem, but we do have some things that really fit well into it really works well to have them as DSLs, and that's not possible with other languages. We also, of course, benefit from like having very concise syntax, being able to prototype rapidly, and not, there are other languages that have concise syntax, but doing so in the context of a type-safe language is really awesome, and that's very unique to Scala. And last, I would say that just encouraging us to think functionally and to think about immutability and information hiding and some of these concepts. Scala really does kind of force us to do things in a good way sometimes. So these are, if I had to look at like what's been great for us over the last 4 years, these are some of the things that I think come to mind. So I'm also going to talk about things we struggle with, and to give some perspective, Spark is somewhat unique, probably different than people writing small libraries or something like that. Spark is really a big piece of software infrastructure that companies make multi-year investments in. So companies will set up huge amounts of hardware, they'll devote entire teams for a time horizon of many years to invest in Spark, and they think of it as like a platform that they're making many sunk investments in. And as a result, that puts a higher burden on it puts some constraints on the way we think about developing Spark, which I'll talk about in the next slide. Another distinctive thing is there's a big library of ecosystem of third-party libraries on Spark. So there's a lot of other people who write code on Spark, and then they write code that depends on other libraries that are also on top of Spark. So we have to think about that as well. And the last thing is just the velocity and size of developers on the project. It's hundreds of developers. We have some that come and some that go. This is very unique, I think, compared with other projects that I'm aware of. So a lot of our perspectives are influenced by this kind of nature of just having a very, very large scale and long-term infrastructure project. So as a result, there's things that are pretty important to us. So one is having backwards compatible and stable APIs. And by that I mean allowing the fact that we want to be enabled to provide this to our users of Spark. Things that you don't even think of as APIs, we have to consider APIs. So our build tool is something we never really thought of as an API. And it turned out when we proposed making major changes to our build tool, it set off a huge chain reaction, and many people downstream, it turns out there's like 10, 15 companies that package Spark and deliver it in some way, and it was going to seriously cause them huge amounts of friction. Some of them said that they would probably have to stop using Spark if we made too major of a change here. I'm happy to say we haven't really changed any major APIs in Spark in the 4 years, even before we had like a 1.0 release. So we're really, really fixated on backwards compatibility, and it does come at some cost, but for us, like, we just consider this essential in building a platform. Also, we care a lot about having a really simple and easy to maintain code base. There's tons of natural inherent complexity in building a distributed system. There's complicated I/O interactions and other things. So we need our code base to be extremely simple if we want anyone to be able to come and work on it and fix bugs and make changes easily. So with those sets of constraints in mind, some of the concerns we've had with Scala and challenges are the following. So one is that it's really easy in Scala to write code that's extremely dense and has high cognitive overload. And I would go even further to say it's not just easy, but it's in some segments of the community like heavily encouraged to be clever and to write code that can optimize for lines of code as the main criteria. And that may work well in some contexts. For us, this sort of attitude and philosophy doesn't work well at all. The other, dovetails with what I just said, but there are language concepts that are really easy to abuse in Scala. It's a powerful language. It has lots of surface area and lots of features, but many of them can be abused if you don't think really hard about the implications of what you're doing. One example is DSLs, which I gave before. Another one is abusing things like option, deciding that you're going to catch any possible exception, even ones that indicate serious like problems with the program, wrap that in an option and pass it to the caller to deal with. Well, sometimes you should be throwing a terminal exception in certain cases, and people misuse these constructs. I'll just talk more about these in coming slides, so I'm not going to dwell too much here. But also the way that Scala as the community itself thinks about compatibility is good. It's improved a lot, so that's something we're really thankful for, but it's still not what I would say is great. Source compatibility between Scala releases is really, really nice. If we didn't have that, it would make it just really hard for us to continue to evolve the project. But you know, Scala still doesn't have binary compatibility and doesn't really plan to. And also the way that many library authors think about compatibility is as like a very much second-class concern. And we've always been hesitant to use many of the kind of ecosystem libraries because they just make huge breaking changes to their APIs very regularly. So these are things that we've had challenges with, but I don't want to just sound super negative, like we want to have a constructive approach to it. So one thing we did today and we announced this morning is that we're open sourcing our own Scala style guide. A lot of the issues I talked about in the last slide, from our perspective, can be solved by just using a little bit more discipline around which language features you use and how you decide to use them. So the philosophy behind this style guide is that code is written once by the author and it's read and modified many times by people downstream. In Spark, that's the case. Maybe it's not in your project, but it is for us, and so we're imposing some constraints and best practices on how to write Scala code. I'll do a quick tour of some things, and I know that like some of this may seem like blasphemy or like it's kind of against the way that Scala is written. My sense is that the whole intent of Scala is to allow different projects to have different philosophies about how to write code, and this is our philosophy. See, they're not happy about this at all, you can tell. So one thing is we really, really don't allow the use of DSLs, basically, except in very specific cases where we've decided to add a new language feature to Spark that is a DSL. So we basically disallow using these operators in sort of internal libraries and stuff. And the long and short of it is like, it isn't easier or better to use these than it is to just use simple descriptive human readable names. So to give a few examples, like, you know, this is the Akka style. I'm gonna send a message using like a bang. For me, having just a method called .send, it's just more explicit. If someone comes and looks at it, they're gonna understand it more easily. If you only save like 3 characters, having a shorter name. So we really, in Spark at least, try to avoid overuse of DSLs. And in particular, if you have DSLs in libraries, well, what if someone's using 2 libraries and they have 2 different DSLs? I mean, like, how are you possibly going to reason about what's happening inside of your program? But we do allow it for certain cases, and in particular when there's like things that logically someone can look at the plus operator and what you're doing is sort of logically consistent with a numeric addition, you know, and they can kind of intuitively get it. But other than that, we think it's too hard to understand. Another thing we kind of constrain a little bit, this one's maybe more controversial, is monadic chaining and kind of the depth and complexity of chains that we allow people to write inside of Spark. So I'm going to give like a simple example to illustrate. Someone already tore this example apart on Hacker News when we posted this morning and said like, oh, you're doing this totally the wrong way. So this is just how we like to do it. So in this example, you have a very simple class called person, and they just have an attribute map. This is say it's some storage system that's, you know, storing data about people. And that's just a very sort of open, non-type safe map from string to string. And then you have a database, which is just a big hash map of people. And I'm trying to implement a function called, you know, get address. So there's one potential field in this map called address. Oh, and one other caveat I forgot to mention. In this hash map of attributes, any of the values can be null. So one way to write this get address, what I want to do is basically, you know, you give me a name, a person's name, that's a string. I'm going to go look up in the database, see if they exist in the database, see if they have if they happen to have an attribute that's address, and if that attribute is not null, and if it is, I'm going to give it back to you. So this is the kind of maybe more canonical way to write this piece of code. So I'm just going to like let people think for 10 seconds about what is going on here to the extent that people can read it. Okay, so basically we do a get into the database. That's going to return something. It may or may not even have a record for this person's name. If it does, and then we flat map on that because it is itself an option. And then downstream, we also have to deal with this case where the result may not be present and it also may be null once we've found this person. So there's a lot of different cases to think about here. So in Spark, we prefer like a slightly more imperative style for this kind of interaction. So this is another version of this function, which maybe people can also look at for another few seconds. So the reason why, I'll just recap what's going on here. Here we break it down into a few cases. First, we check if the person is in the database. If not, we can immediately short circuit and return none. Otherwise, we look up, we assume they're in the database, we look up their record, and then we deal with three cases. One case is they didn't have the address field, one case is they had the address field and it was null, and one case is that they had the address field and it was correctly populated. So you can look at this later, but in general for us, the code on the right is much easier to understand quickly, to modify, to figure out which cases you need to cover if you unit test, and so forth. And we definitely try to avoid extensive amounts of chaining, especially when there's options and other things inside of there. So we actually, a question? Yeah.
Yeah, sorry, so I agree with your comparison between these two examples, but what about for comprehensions? Wouldn't you agree that that's quite readable?
Yeah, so I think that was actually the exact feedback that someone had this morning. So I'm not saying this is the only way to write it. I think also a for comprehension would be fairly easy to understand here. I think mostly we're trying to say that the one on the left is maybe, it can be confusing for people to modify. So we have some guidelines. These are a little bit subjective, but we try to avoid chains that are really long. We try to say if the chain is really complicated, then break it up into multiple pieces. And we also say that once you use a flat map, you should break the chain, because otherwise trying to reason about the types propagating through the chain is really hard. And also one other thing to keep in mind, a lot of our users and contributors are not Scala experts, and they don't have a lot of familiarity with Scala. So we bias towards making things more explicit and even like Java friendly, whereas maybe for your code base that's not the case. So so that was kind of some high level impressions and announcement of our style guide. I also want to just cover a bunch of other topics that we found using Scala in the past. So one issue, as I said, is we care a lot about binary compatibility for our users. And the reason why is if you go into a traditional enterprise, they're making some huge investment in Spark. They actually had a lot of Spark jobs that have been written, and now the people who wrote those jobs work at a different company, and no one knows where the source code is, and they can't recompile it, and they want to continue to upgrade and use newer versions of Spark. So this kind of requirement pops up. I think overall, like, in the future, I'm hoping that we can have an ecosystem where everyone can just build from source, but that's not the case in the modern world of software development. But let me step back a little bit and just define some terms. So what does compatibility even mean? So what it means is when we upgrade and add a new version of Spark and put it out there in the world, what are the implications for users who are using the old version? That's like the high level bit about compatibility. And there's different types of compatibility. So one is source compatibility. That means that users who built applications on Spark can recompile them against the new version, and it's all fine. They won't have to make any source code changes. A more strict version, I think mostly more strict, is binary compatibility, which means they already compiled their thing. They have compiled bytecode. Can that run against our new version of Spark safely? So in Spark, we guaranteed within our major releases binary compatibility. And that has implications to kind of be able to deliver that promise. So the long and short of delivering binary compatibility, there's some obvious things, right? Like you can't just remove functions that were there before because they won't be there anymore, and then the person's program will fail. That's like the obvious thing. There's other things like in Scala, the names of arguments actually become part, I think, of the binary signature because it allows, because of just the way that the language deals with arguments. It's different than Java. So those names we're committed to. So if we have like a shitty name that someone didn't think about and they merge quickly, it's a problem. Is this wrong?
It's only for source compatibility.
I see. Yeah, so I mentioned before that like binary compatibility is strictly more than source compatibility, but it's not true. Like in some cases you could actually preserve binary compatibility and break source compatibility. So we want both in Spark, and that's why we can't change the argument names. So thanks for that clarification. Also, because Scala itself does not promise binary compatibility between 2.10, 2.11, et cetera, we have to then cross-compile for both or all kind of active Scala versions in order to provide this, because someone may have themselves been using an older version of Scala. So the nice thing is that we even can cross-compile, because in earlier versions of Scala, there was breakage in source compatibility, which made it really hard. So, and then there's other things like, so the basic things are just don't remove APIs that you had before. That's pretty intuitive. There's other things that you might not think of. So one issue we've had that people will randomly do this and not realize it's going to break for our users is you can't add concrete members to a trait even if they have default implementations. And So let's say I have a trait called person, it has a def that gives you its name, and then I want to add a new thing that gives you its age. It's very natural to add new fields. And I'm going to create a default implementation where, if you don't decide to override this, then it just gives back none. So this is a pretty intuitive thing, I should be able to do this, but because of the way that traits are compiled into interfaces and corresponding objects in Scala, it actually breaks binary compatibility if you expect other people to be implementing this trait. So that's not intuitive. It's not the kind of abstract class view of the world. It's different than that. The nice thing about this, oh, sorry, a question in the back.
Just a comment, this might change in future versions of Scala, like once the Java.
Yeah, so I think this is going to change hopefully in future versions of Scala. And actually for us, we haven't had, this isn't something that's a huge problem, it's very easy to accidentally do this. But there are some nice things. So one is if you don't expect other people to extend the trait, like you're just using the trait in your own project and maybe some of your exposed classes inherit from the trait, it's actually okay because people will always get the most recent version of every implementation of that trait. But it will throw errors in binary compatibility checks. Another thing is if you can use an abstract class and that works, then you can just use that instead. One other gotcha with binary compatibility is the way we deal with return types. So in Scala, the compiler, if you don't give a return type, will infer what the return type of a function should be. So let's say I have a function called getRDD, and it returns mapped RDD. That's a particular subclass of RDD. And then I want to upgrade it, and I'm actually okay, well, now I want to return this other subtype of RDD. Well, because of the inferred return type here, the compiler is going to return the most specific type, which is mapped RDD, and I change it to filtered RDD, and that's going to break. So the way to fix this is pretty straightforward. You just need to declare the return type you want. And as a policy in Spark, we force that every public method have an explicitly declared return type just to avoid this potential problem. This one's kind of bad because you don't realize until you want to change it that you already screwed it up and that there's no way to change it, to fix it. So this is just good practice. It's part of our style guide, and I think maybe even in the public Scala style guide, this is encouraged. But it's kind of a gotcha that we've had to deal with over the years, and now we take care of it. So then the question is, how do you verify binary compatibility? There's a tool from TypeSafe called Mima. It's pretty outdated, but it is a very useful building block. I think it was basically a forked or somewhat copy-pasted code from a very old version of the Scala compiler. But what's really cool about this is we can use this tool when someone submits a new patch to Spark. That patch will actually fail our validations, and we will never merge it if they break binary compatibility. We had to add some extra tooling here because we use package private and other visibility modifiers, and we don't consider it breaking if we break something that someone else cannot access because of package privacy. And I think the default built-in thing doesn't take that into account. So we've basically hacked our way around it, and we have something that kind of works, which other projects are welcome to use as well. I think one thing that could be cool in the community, if anyone's interested, is to build a really nice, awesome compatibility checker that does take into account these things like package privacy, and maybe it's using newer mechanisms than just forking the old version of the compiler and stuff like that. So that's a nice wish list thing if anyone's interested in doing that. Okay, another big thing that's important to us is Java APIs. I have a conjecture here. I have no way to prove this, but my instinct is that if you look in the future, 2-3 years in the future, and this may be true already actually, the most popular Scala projects will be the ones that have Java APIs. And it's just because there's such a bigger ecosystem of potential users of those projects. So for us, Java compatibility is important. And some topics in exposing APIs that are written in Scala to be callable in Java. Well, it turns out it's actually not that hard. A strawman version of it is you just avoid language features that Java invocations will get confused about and not be able to run correctly. So you avoid default argument values, implicits, returning a Scala collection. That's a simple one. You just convert it out to the Java format, and things like symbolic method names. So if you have some subset of APIs you want to be callable in Java, you just need to follow these rules basically, and you can actually do it pretty easily. The only caveat I would say is that you need to do explicit runtime testing of everything you want to expose in Java, because there are Scala compiler bugs that in this area of what you're trying to do. I mean, we've hit many bugs over the years in this type of interoperability, and the Scala team has helped fix a lot of those bugs, which is great. But the fact that we hit so many of these bugs makes me think that like not a lot of other projects are trying to do this, and I would really encourage Scala projects, try to provide Java APIs. Even if they lose some of the magic that you have in your Scala API, you'll get a lot more users of your project. And I do feel like Java interoperability should be like a very first-class important thing in the Scala community. At least I hope it will, because I think it will increase the user base a lot. Okay, a couple other just topics that I had thought of to mention. So one is performance. I think Reynold Shin covered this in his talk earlier today. But people often ask about like, oh, how do I think about performance of Scala, and especially compared with Java counterparts and stuff like that. My number one thing about performance is that you need to understand when performance is important and when it's not. And prematurely trying to worry about optimizing things is really not a good way to go. So in Spark, for instance, it's kind of a control plane, data plane model. We have these, some of the kind of control plane issues like scheduling a particular job and launching tasks and creating thread pools, and those happen like order a few per second. And then we have the data plane where we're actually crunching potentially large amounts of data inside of each JVM, and that's doing much more intensive operations, like it's iterating through maybe millions of records in a second. So the control plane stuff, we don't sweat it too much. We don't worry about performance. It's totally acceptable. Some of the things where we do care down to like CPU instruction level of performance, then that's when you need to care. So step one for performance is like, don't stress too much about it. Figure out what's important in your application. And when it is important, we do have some guidelines. So in general, we prefer using Java collections over Scala ones. And it's not that the Scala collections aren't performant in some cases if you're using certain methods. It's that the overhead of trying to trace through the collection hierarchy to figure out, like, if I call dot size, is it going to be O of n or is it going to be constant time? And like, if someone comes and changes this code later to use a slightly different implementation of this collection, is that going to impact performance? That cognitive overhead is like too much for us, and we usually just drop in a Java collection here and then don't think about it. Also, there's some esoteric things. I think in older versions of Scala, maybe it's still the case, while loops and for loops have like drastically different performance properties, because for loops compile down to something that creates a closure and has fairly high invocation overhead for every iteration, and while loops don't. That's not obvious, but it can have a huge impact on performance. Another thing that's kind of not obvious is that if you're accessing members of fields, if you make them private the ability of the JRE to do runtime optimization is much better. Private in Scala means that other members of the class can still access that field, which because of that property, it's harder for it to optimize at runtime. So if you don't need that property, use private this. I don't think many people use this in Scala right now. We have this all in our style guide, but just some things that came up. So for IDEs, another topic of any big Scala TVs to think about. We use IntelliJ mostly. I would say it's not something we've all thought about religiously and done a rigorous comparison. Basically in 2013, a bunch of us that were working on Spark, like one guy started using IntelliJ and he was like, oh, this crashes like a lot less than Eclipse when I'm doing Scala stuff. And then I started to use it and I was like, yeah, this is like seems more stable. And then other people started to use it. So it's very, I'm not going to claim that this is like currently the best solution, but we have been using it and we've been pretty happy with it. I think the Eclipse side of the world has also advanced a lot in the last year and a half. So I can't provide a more current comparison, but we are pretty happy with IntelliJ. A couple other things, so build tools. So for a long time in Spark, we supported two entirely separate builds. We had a Maven build that some people added because they didn't know how to use SPT, and then we had an SPT build that was kind of the original build that started with the project. And I will say 3 years ago, SPT was very hard to use, much harder to use than it is now. It's improved a lot. So this is what I mean when I say compatibility issues. Like, we wanted to throw out one of these builds, and getting any consensus around which one to throw out became total religion and completely impossible. So I had a like Henry Kissinger like role of trying to negotiate what the project was going to do here, and the solution we settled on was that we currently use Maven as our reference build, like the build where we guarantee we fix any dependency issues and make sure that it works. But we use this thing SPT Palm Reader, which is a little known plugin that lets you actually inherit project structure and dependencies from Maven in an SPT project to allow us to get the access to incremental compilation and the REPL and all this nice stuff in SPT. So this kind of works, to be honest. I would never recommend anyone do this unless they absolutely have a gun to their head, which is like what the situation we were in. Just choose a build tool and use just one of them. But I was very thankful that like people had built this tool because it really, really helped our problem in Spark. So that was great. Also, I will say, just in general, SPT has gotten much, much easier to use, simpler and better documented in the last 18 months, and I think it's had really, really major improvements. But I did want to put a little comparison here. Just, I don't know if people even are still thinking about using Maven in Scala projects. Like, we might just be the only ones. But I did put a comparison just based on, we have this great perspective because I literally maintain the same build in 2 different systems, so I know exactly like which one is, you know, what's easier and what's harder. I did make like a little list here if people want to ever think about how to choose one build tool or another. Basically, the long and short of it is, the basic things are really easy. If all build tools know how to have multiple modules, they can invoke the compiler, they can sort of do continuous compilation. What you care about is like, what if I have to do something that's even remotely a little bit more complicated than that? And what it really comes down to is like, what language do you want to write your build in? Do you want to write your build in Scala, or do you want to write your build in like a really complicated XML format? And then if you want to extend the build, how do you do that? Frankly, SPT has much better answers in my mind than Maven for either of these 2 questions. So like today, if you're starting a project, I would absolutely like 100% just recommend using SPT. It's much more integrated into the Scala ecosystem, and it's much easier to extend it. And maybe if I'd pushed a little bit harder, we could have just settled on SPT only as a build tool, but we didn't do that. And now I'm writing like Maven plugins, and it's just god-awful. So a couple other things. The way they do dependency resolution is fundamentally different. You won't run into this unless you have a big complicated project, but the big tricky bit of dependency resolution is how you deal with conflicts and different versions of the same library that exist in your graph. And Maven and SPT have like fundamentally different resolution styles. So maintaining those together is not very fun. Yeah, so this is just some perspective on build tools. Thought I would throw it up here. I know there's newer build tools now, and people use Gradle and stuff like that. I have no experience with those, so I can't comment, but I'm sure there's also other things to look into here. And then a couple of more things. So one thing is like, what book do we use to train new people in Databricks and like get people up and running with Scala? There is this book that like is the most hipster thing. It is almost impossible to get a copy of this book. I had to like personally PayPal the guy who wrote it, and it's like he has a janky little website where it has like this book listed. It's not on Amazon, it's not on the TypeSafe list of Scala books, but so because it's so generally hard to find and learn about, I did want to comment on this book is actually pretty good as a beginner Scala book. What I really like is it builds like very incrementally on new concepts. So if you're able to get a hold of this book, and you know, one of the maybe like 10 copies of this book that exist in the whole world, you should definitely check it out. We bought a few copies of Databricks, and it's kind of like what we give people the first time they pick up Scala, more than some of the kind of better known books. Another thing is, oh, and I didn't include the author on this. I forgot. I think it's a professor somewhere. Okay. So whoever that is, maybe, is that person at this conference?
No, but he's a pretty famous author.
Okay. So anyway, I think there's also an ebook form of this that might be easier to get, so I just would recommend checking it out and putting it up here because I've noticed like not many people know about this book. Another thing is like, where do you report issues for Scala? Sort of a simple thing, but there used to be not very good SEO, so it was really hard to find this if you Googled for it, but now it's great. I just Googled like yesterday, issue tracker Scala, it just came right up. But the Scala team is pretty responsive to issues. Like, it's just like any other project. Try to come up with a reproduction, try to simplify it, try to write a good description. And if you do that, they'll fix it in many cases. I've noticed it's sort of bimodal. Like, either they'll fix it within like 2 hours in an insanely like good response time, or like it's something where I think maybe they're not sure what the problem is, or like no one's maintaining it, and like it won't get fixed for a long time, and I have to just keep bugging people. But they do a pretty good job of working through the like good open source practices and will fix bugs and stuff. So definitely check that out. And I know TypeSafe also provides commercial support, so that's another way to go. But if you're going through the open source channel, we found this is pretty useful. Okay, so to wrap up the talk and leave a few minutes for questions, basically the long and short of it is Scala has a huge surface area, lots of really cool, powerful features, For our use case, with the size of the project and the velocity of change in the code base, we found that it does help to just constrain a little bit the way that, like, what people can do, and maybe put handcuffs a little bit on people to just get them into a working set of Scala that we think is manageable. Our philosophy is really to just keep the internals and especially the API really simple. And maybe you just do one and not the other. Like if you're writing a Scala library, maybe you're using crazy implicits and all kinds of DSLs and stuff inside of your library. But if you keep the surface area nice at least, then you're kind of shielding your users from that complexity in a way that can be nice. And just again to say, like, we're our own project, we have our own conventions. This might not work for everyone, but this is definitely the way that we like to write Scala and how we think about evolving with Scala. And so with that, thanks a lot for your time, and I'll take any questions. Also, I just, so you know, I have to run to the airport pretty quickly because we have our own user conference in New York, like tomorrow morning really early, but I'll try to stick around as long as possible after this to chat with people. And there is a question, yeah.
Actually, a comment. The atomic Scala book actually is co-authored by Diane and Mark. She's doing the keynote tomorrow. So if any of you guys are interested in the book and want to know more of it, I would definitely check out Diane.
Fantastic. So in case people couldn't hear, I think you were saying one of the co-authors of that Atomic Scala book is giving a keynote tomorrow morning. Is that right? And her name's Diane Marsh. So you can finally go and get a copy of this book. Maybe if you go talk to Diane Marsh and ask her what's up.
The second edition was just published a week ago and it's available on PDF on their site.
Oh, cool. So there's an ebook, another comment, there's an ebook of the second edition on the website, which is great. Do you know if you can order the print book still? Yeah, it's very hard to get a print copy of this book, but if you go up and ask the keynote speaker, maybe she has some and can give you one. Any other questions or comments? Sure.
Question about this style, Scala style.
Yes.
How is it different from type-safe Scala style, and do you use Scala checks approach to forces?
Yeah, those are great questions. So the question, I'll repeat it. How is our Scala style guide different than type-safes? And do we enforce in any way programmatically style checks? I'll start with the second one. I totally forgot to mention this. We use a tool called Scala Style that is a great community tool to do exactly this. If someone submits a patch to Spark and they violate at least some of our style conventions, it immediately fails and they have to fix it. That's the only way you can scale it with 100 of people contributing every month. That's an awesome tool. We've extended it a little bit. Totally recommend that for your own project. The second question, how do we deviate from type-safes? I actually think we don't directly oppose the type-safe style guide. I think that we cover areas that the type-safe guide has no opinions on. I think the type-safe guide tries to leave open a lot of room for people to do their own thing, and so we have gone and filled in the gaps and maybe in some cases added more restrictions than exist in that guide. Yeah. Anyone from type-safe? Maybe I'm not characterizing that correctly. I don't know. So I'm happy to let type-safe people chime in as well. Any other? Did you have a question? Yeah.
Yeah, I was just wondering about binary compatibility for how many versions do you keep in order for the whole 1.x series?
Yeah, so the real question is for how much time, because you can arbitrarily change versions. So for 1.x, we promise compatibility. In the Hadoop ecosystem, usually that major release will exist for order of 2 years or so, something like that. Yeah. Okay, any other questions? Okay, great. So thanks a lot again, and I'm happy to be here. And thanks again to TypeSafe.